Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, are you ready to crunch some numbers and learn more about solutions? I am. In today's video, we're going to do some calculations using molarity. So let's go to my screen. Let's talk about how you're going to make a solution from a solid. You're going to take the amount of your solid substance. You will weigh out the amount that you need. And in most textbooks, they say you're going to put this into a volumetric flask. Volumetric flask, here is actually a picture of it, what it looks like, is only one tick mark. And this one tick mark will tell you then the volume. So this is 10 milliliters. If your meniscus then touches the bottom of a tick mark, you know you have exactly 10 milliliters of a solution. They come in 50 milliliters, 100 mils, 250, 500, 1 liter, 2 liters. So they come in different volumes, but they only have one tick mark. They are calibrated for room temperature and the volumes as well. I do not like this method because many times a solid will get stuck somewhere on a neck or maybe on a side here of a volumetric flask, and it's very, very hard to get it out. So I think we're going to modify this. So you're going to take your solid, whatever the amount you need, and then you will put it first in a beaker with a little bit amount of solvent, usually water. And then you will, probably I'm going to say 1/3 or about 1/2 amount of what you need of a total volume. Dissolve this solid first in a beaker. And then when it's dissolved, you will pour it in a beaker. And then you will add the rest slowly water. You will add the water just below the neck. And then you can use graduated cylinder to do that. And then slowly with an eyedropper, you will add to the very, very end. So you will have on your neck of a volumetric flask, you will have your tick mark, and you will want to add the liquid so the bottom of the meniscus touches it right there. And that's how you end it. And you're going to do it drop by drop with an eyedropper at the end. So that's how you're going to make these, to make a solution. I think we can look here and we can quickly do some quick calculation. Actually, let's quickly add a page. Let's add a page here to do some calculation. So we have ammonium dichromate, and here on a scale, it says we have 90 grams of it. And then we added it to the flask. Let's just say we dissolved it in some water. We added here, and then we added water to the end of, this is a 250 milliliter volumetric flask. This picture also shows you that if you have 200 ml of water, you will not be able to add all of 250 milliliters into your volumetric flask. It will be actually less, but your solution volume will have 250 mLs. So just keep that in mind. So let's actually calculate the molarity of this solution, what we did. The definition of molarity is moles of my solute per volume per liter of my solution. So molarity is moles per liter. And we are going to have 90 grams of ammonium dichromate. If I have 90 grams of ammonium dichromate, I need to know moles, right? It's moles. So let's go here and let's find out how many moles I have. So ammonium dichromate molar mass of it. Do you remember how to do molar mass? I'm going to look at periodic table at the molar masses. So the molar mass of this is 252 grams per mole. And if I have 90 grams of ammonium dichromate. Let's change it to mole. So I have 1 mole. It will be 252 grams, and that will give me 0.357 moles of ammonium dichromate, Cr2O7. And I also then, this many moles were, so let's put this, so I have 0.357 moles in 250 milliliters. 250 milliliters is 0.250 liters. And I plugged into a calculator, and I have 1.43 molar solution. So there you go. We calculated the molarity of a solution that was made in this picture. Let's go forward. Let's go a little bit harder. So let's say we want to make 200 milliliters of 0.1 molar solution of sodium hydroxide. Okay, so let's go here for a second. Let's go here. So I want 0.1 molar. 0.1 molar. 0.1 molar means, so 0.1 molar, it means I want 0.1 moles per 1 liter of solution. But I look, and I need to make 1/5 of that volume, yes? So my volume, but I have 200 mils, so that's 1/5 volume of that. If I have 1/5 volume of it, I'm going to take 1/5 of my solute. So if I take 0.1, so quickly 0.1 divided by 5 will give me, what will give me? 0.02 moles. I will need 0.2 moles in then 200 milliliters. Or we can do some, actually show you some how to do an equation. So this was very like conceptually, how to think through common sense, but you can also do that. So let's start here. We have 200 milliliters. Yes, I'm going to have times where I have 0.1 moles per 1 liter. Yes, and I need to cancel out my liters. So I'm going to say, well, 1 liter is 1,000 milliliters. And I quickly cancel my units, where here is my milliliters cancels out, here's my liter cancels out. I'm going to be left with moles. And I crunch some numbers, and again, voila, 0.02 moles of sodium hydroxide. So then sodium hydroxide is molar mass 40 grams per mole. So now quickly, let's do this. I have 0.02 moles of sodium hydroxide times, well, what do I have? 40 grams per 1 mole. And I'm going to have 0.800 grams of sodium hydroxide is needed. So what am I going to do? I'm going to measure out, and actually there's only 1 sig fig here. There's 1 sig fig here, so you do not need the zeros. So because everything was given 1 sig fig, so you can say 0.8 grams of sodium hydroxide. So what will I do? That means I'm going to weigh out 0.8 grams of my solid sodium hydroxide. I'm going to dissolve it in about 100 milliliters. I'm going to take half of what I need. In 100 milliliters, I'm going to dissolve it in a beaker, and I'm going to transfer it to a 200 ml volumetric flask. Then I'm going to use my graduated cylinder to transfer more water in. And then when I am just, here is my tick mark, when I'm somewhere a little bit below, I'm going to start adding eyedropper, drop by drop, slowly until my meniscus touches the tick mark, and that's when I am done. So I need this much of my solid. Okay, are you ready for another problem? Let's go. Let's try this. Here is copper sulfate. Copper sulfate makes this beautiful blue solution. So let's say we put 25.5 grams of copper sulfate in 1.75 liters of my solution. And the question now is, let's find the molarity of it. Let's do it. Here we go. A copper sulfate solution. Copper sulfate makes this beautiful dark blue color. Or if it's concentrated, it's dark blue. And let's do this problem. Let's say we're going to put in 25.5 grams of copper sulfate in a 1.5 liter solution, and let's find the molarity of it. Well, again, molarity is moles per liter. I need to know my moles. So let's take the 25.5 grams of copper sulfate and change it to moles. So 25.5 grams of my copper, it's copper 2 sulfate, and let's do 1 mole of copper 2 sulfate is, if you add everything up, it's 159.55 grams. So that will give me, with my correct number of sig figs, 0.160 moles of copper 2 sulfate. And now here is my moles. I have 0.160 moles per 1.75 liters. And plug and chug into your calculator, and we have 0.0913 molar solution. Remember 3 sig figs. So here it is. It wasn't too hard, right? Okay, let's keep talking a little bit more. How do you make a dilution? So how do you make a solution from a very concentrated stack solution? So in the other 2 examples, we used solid to start. Now we are going to already have a solution. So let's go through quickly, steps by steps, what we're going to do. So you're going to take your concentrated stack solution. You will calculate how much volume you need to take out. I will show you that in a second. I'm going to take out this volume. We're going to transfer our pipette into a new volumetric flask with a tick mark for the volume that we need. You will transfer, dump it all in, and then you will add the rest water. Again, you will add it slowly to make sure that the bottom of the meniscus then touches the tick mark that you have on the neck. Okay, what I need you to think about is this. The amount of solute that's in this pipette. So the amount, let's say moles, M-O-L, the moles that's in the pipette. You transfer it here and then you dump it in, then you add water, but the amount, the moles, is still the same, right? So because they were in the pipette, you just added more water. So the moles in the pipette has to equal moles right here in this volumetric flask. Okay? If you understand that, things will become pretty straightforward. So let's go to this problem. So we have a stack solution, and we have a 6 molar hydrochloric acid, and we want to make 100 milliliter of 0.1 molar. Okay, let's go through this really, really fast. So we need to calculate what's the volume of our stack solution that we need to take out. But do you remember how do we figure out the volume? Okay, let's think through this really, really fast a little bit. So molarity equals moles per liter. Liter is my volume. So if I quickly multiply molarity times liter equals moles, yes? Wait a minute. Moles is the amount in my pipette. That's the amount. Moles is an amount. So I need to say moles of my solute in the pipette. So my moles of my stack solution has to equal moles of my diluted solution. Yes? So if moles equals moles, hold on. Molarity of my stack solution and volume of my stack solution equals molarity of my dilute solution and volume of my dilute solution. Many times people say that means M1V1 equals M2V2. Okay, so let's think about this for 1 second. Let's go here. Do I know molarity of my stack solution? Yes, it's right there, 6 molar. I'm going to say 6 molar. Do I know the volume of my stack solution that I need to remove? No, I do not know. That's what I'm trying to calculate. Volume of my stack solution. Do I know now molarity of my dilute solution? Yes, right there. So we're going to say, oh, so we have 0.1 molar. And do I know the volume? Here it is, 100 mils. Now you can put this in liters or milliliters. As long as the units are consistent, you are okay. So I'm going to put that 100 milliliters because that means, well, let's think about this. That means volume of my stack solution is 0.1 molar, right, times 100 milliliters. And then I'm going to divide it by 6 molar, right? And then quickly my units, my molarity will cancel, and I'm going to be then left with volume in milliliters. And then if you plug this into a calculator, you will see I need 1.67 milliliters of my stack solution. So what does this mean? I'm going to take 1.67 milliliters into my pipette, transfer it over to 100 milliliter volumetric flask, and then I'm going to fill water to the 100 ml mark. That's how I'm going to do it. All right, we good? Ready to do some problems? Some more. So here is another question for you. How many liters of a 0.25 molar sodium hydroxide solution contains 0.255 moles of sodium hydroxide? What's going on here? Well, remember, molarity means moles per liter. So let's start with what we have. So we are going to start with 0.255 moles of sodium hydroxide times, what are we doing? Well, molarity is moles per liter, but I can also turn it upside down, right? So if I put, here we go, if I put 0.125 moles of sodium hydroxide per 1 liter, yes, of sodium hydroxide. There we go, right? I can use it this way also. So if we're going to do this, our moles will cancel out. I'm going to get liters. So to do this, I'm going to have 2.04 liters. See, that wasn't that bad, right? So we have 2.04 liters of 0.125 molar solution contain 0.255 moles of sodium hydroxide. Let's go a little bit more. So how many milliliters of 0.155 molar potassium chloride solution contain 2.55 grams potassium chloride? Are you ready? So now we have 2.55 grams of potassium chloride. The other problem was a little bit easier because we started with moles. But now we have grams. So it's a very similar setup, just a little step. We have to do a little more step. So what do we have to do? So we have to take these grams of potassium chloride and let's change it to moles. So let's do that first. So we have 2.55 grams potassium chloride, yes, and molar mass of potassium chloride. If you're going to add potassium and chlorine, we're going to have 1 mole of potassium chloride is 74.55 5 grams of potassium chloride. And that we plug and chug, and we will have 0.0342 moles of potassium chloride. Okay, now we have moles. Now this problem looks the same like other problem, right? So now we're going to take our moles, 0.0342 moles of potassium chloride. And remember, we're going to say, wait a minute, we have 1 liter is 0.155 moles potassium chloride. And we can change, well, the problem is asking us for milliliters. So let's erase this. Let's keep going. But we need to change the liters to a milliliter. So I'm going to say then times, well, there is 1,000 milliliters in 1 liter. And now my units, yes, moles cancel out, liters cancel out. I'm going to have milliliters left. And I plug and chug into my calculator. And I'm going to get 221 milliliters. So there we go. Okay, one more. Ready? One more. So here we go. What volume of 6 molar sodium nitrate solution should I use to make 0.525 liters of 1.20 molar sodium nitrate solution? This looks like, what does this look like? Doesn't this look like my dilution problem? Do you remember? Dilution, we're going to say moles in my pipette. Yes, moles of my stack solution will equal moles of my diluted solution, yes? So I'm going to say, oh, M1V1 equals M2V2. And now I'm just going to plug and chug. So stack solution first. So I have 6 molar. 6 molar, and volume, I do not know the volume. So, and now molarity is 1.20 molar, and my volume is 0.525 liters. So quickly, so my volume that I will use is, well, 1.20 molar, and then 0.525 liters divided by 6.00 molar. And again, my molarity cancels out. I'm going to have liters, so the volume will be in liters. And if you plug this into a calculator, plug and chug, you're going to get 0.105 liters. It's asking you what volume, or you can say 105 milliliters. And that is it. So we learned about molarity. We learned how to do a solution from a solid. We learned how to do a solution from a concentrated stack solution. And we learned how to do some calculations with molarity. So I hope you learned a lot, and see you next time.